So I got a take two on part two of our Is the Moon Landing a Hoax? I had a audio issue on the last one. I appreciate someone pointing that out. If you are wondering about if I'm not why I'm not talking about particular things, there is a part one, and there's definitely a part three, and there may be four and possibly even five, depending on how much material I decide I want to put into this. So what we're going over is various claims that people who believe the moon landing was a hoax have made, and arguments counter to them. So some people suggest that all the moon action didn't happen on the moon, but was actually recorded somewhere in the desert, somewhere, perhaps in the southwest of the United States. Uh, this is pretty easy to shoot down because it would have been really difficult to do the lighting in that kind of situation. They obviously would have had to do it at night because you would have had blue skies on the Earth, and it would have been really hard to filter that with that technology of that time period. You don't have any stray bugs, which you do get in the desert, quite a few, especially flies. If you're doing anything out there where you have any kind of water at all, you're going to draw lots of flies. And no wind comes through and kicks up the dust or anything like that. So that seems pretty implausible. Uh, One of the things that kind of discounts the idea of it being like a closed sound stage is if you watch the way the dust kicks up uh, in the videos. A couple of things to keep in mind. Video technology was pretty primitive back then. The idea of doing this in post production would have been a major work. Doing this on the fly would have been nearly impossible with that kind of technology. So when you watch dust in the various moonwalks, you'll see uh, the dust rises very high, almost unnaturally high, and then dissipates very quickly because it's falling rapidly. So the dust rise indicates low gravity. The rapid fall indicates a lack of air. So these are two conditions that would be very hard to duplicate on Earth. You might be able to do one or the other, but both would be very hard. It's possible that they may have found some particular dust that might mimic this behavior, but again, it'd be hard to find because in order to get something to fall rapidly, it would have to be dense. And if it was dense, it wouldn't rise as high up off the surface as it did. Some people have suggested that you could duplicate some of the dust effects by filming the action in a vacuum chamber. And yeah, you could get the rapid fall effect because there would be no air resistance against the dust. But this is pretty much easy to shoot down because the world's largest vacuum chamber measures 100 feet in diameter and was constructed in 2010. Prior to that, much smaller. You would not have had enough room to film this kind of action. So, probably one of the big crux arguments comes around the Van Allen belt and various things that happened with James Van Allen. So, one of the claims that's made is that Van Allen thought that manned space travel was impossible due to something that's quoted in a 1959 Scientific American article. The quote that they take from him is, quote, since a human being exposed for 2 days to even 10 redogens would have only an even chance of survival, the radiation belts obviously present an obstacle to spaceflight. And then what they like to add later is, I jokingly call it, they got to him later. And this is quoted from the Collier's book on the moon hoax. Quote, when asked how the astronauts could survive a prolonged journey through intense radiation, I know the issue of intensity is another controversy. The book states that Collier reported that Van Allen said, "Well, my original calculations must have been an error somehow." No such quote or interview exists. If you hear other people using this in videos and books, it all goes back to Collier's book as the original source. Collier has no source for this. So here's the actual quote, because I kept on hearing this so often that I actually went and purchased the 1959 Scientific American issue that has the article in it. And here's the actual quote. Quote, "Since a human being exposed for 2 days to even 10 redogens would have only an even chance of survival, the radiation belts obviously present an obstacle to space flight. Unless some practical way can be found to shield space travelers against the effects of the radiation, manned space rockets can best take off through the radiation-free zone over the poles," as kind of depicted in that picture there. "A space station must orbit below 400 miles or beyond 30,000 miles from the Earth. We are now planning a satellite flight that will test the efficacy of various methods of shielding." So when he made this initial quote, they had only launched the first two initial probes through the Van Allen belt. And it was through the densest areas. So they'd launched many, many probes by the time human beings were going into space, and they had a much better idea what was going on at this point. So clearly, Van Allen's not saying it's impossible. He's saying, with the information they have, it doesn't make sense to go straight through the densest parts. And he actually comes up with an idea of basically leapfrogging from a polar space station to the moon, which you'd see in a lot of early 60s articles. People thought that might be the way we were going. So another item on the radiation is people point out that many of the animals launched into space died. How do all these animals die and humans somehow survive? Well, the reason is because most of the animals weren't up there to be retrieved. Most of the space animals died of trauma and deliberate non-recovery, meaning that they either didn't bring them back or re-entry was some kind of ended up having a failure on life support. No space environment or radiation deaths have been acknowledged. Now, there's a chance there's a few of them, but it's going through the material, I saw that pretty much trauma and non-recovery were the primary culprits. So, how come people who take X-rays stand behind a lead wall to avoid radiation exposure, and the astronauts somehow survive behind thin-foil walls? Well, it's because, and this is something that you can look up pretty easily online. You can find it in Wikipedia, but you can find it in scientific articles as well. Solar radiation comes in two primary forms: electromagnetic and particle, in the form of charged protons and charged electrons. All energy travels via waves. Sound, water, light, radio, radiation. Sound and motion transfer energy by molecules imparting their energy into adjacent particles. High energy transmissions like light, radio frequency, and waveform radiation also appear to travel in waves. However, at this time, there's no actual physical particle as we understand it at present. So we fill in this particle with something called a photon. Photons are a quantum theoretical particle that stands in to explain the movement in waves. A photon has no mass, at least none that we're aware of at this point. So when the sun has a big ejection, two forms of radioactivity are transmitted: electromagnetic, which has no mass and travels at a constant speed of light, The second form of radiation that's kicked out is particle radiation, which has the mass of a proton or electron and travels at a speed based on the force of the explosion and the amount of matter propelled by that explosion, or mass to be more concise. And the speed will attenuate based on barriers in the space environment. So this is how we get space environment warnings, where we see a flare or a core eject of some sort. And then we say, oh yeah, in the next several hours or the next several days, we're going to have X amount of energy imparting against our satellites and possibly messing up our comm system. We know this because the electromagnetic travel at the speed of light telling us it happened. And then we know that there's a follow-on mass of energized particles following along at a much slower speed. So the Van Allen belt has to be particle in nature. It can't be waveform radiation. No item of physics in the vicinity of the Earth has the power to capture and concentrate waveform radiation. Waveform radiation behaves very similarly to light. The only thing that can bend and capture light that we know of is a black hole. Same would be for other types of waveform radiation. Particles, however, can be captured by gravity, and charged particles can be captured by magnetism. Two things the Earth has. If the Van Allen belt were lethal, and the Apollo spacecraft merely a fabrication, why not just fake a craft with a thick lead cabin, or claimed some kind of classified breakthrough in lightweight composite material? They made it known that the foil was very thin. So clearly, they weren't afraid of when once people applied the physics of the situation, they didn't expect anyone to scientifically go, oh, well, there's no way thin foil could work. So let's explain that. So satellites, which some people who believe that the moon landing was a hoax also believe satellites don't exist either, but satellites only have a few centimeters of aluminum protecting their equipment. Now, a human being could survive numerous charged particles without it necessarily being a lethal event. It could potentially cause some long-range problems. However, delicate electronics would suffer an ESD event from most interaction with a charged particle. So if satellites couldn't exist, or at least let's say they can't pass through the Van Allen belt, we would not have been able to discover the Van Allen belt in the first place, because any instrumentation that went into it would be rapidly taken out. Without that instrumentation surviving the interaction, we would know little to nothing of the strength, its bands, and its range. Space radiation can't be detected from the ground. Radioactive particles in a cloud cannot be detected from the atmosphere or low Earth orbit. Many satellites pass through the Van Allen belt numerous times a day. Some are specifically designed to detect space weather, others designed for recon and communications. These satellites spend as much as a decade passing in and out of these fields. The inner belt is made up of protons. The outer belt is electrons. The belts have been far better mapped from when Van Allen made his original statements. Transit through the inner belt lasts a matter of minutes, and the outer belt lasts around 90 minutes, much shorter than the 2-day period that that Van Allen was talking about back in the Scientific American article. So why do we care about the difference between the waveform radiation and the particle radiation? Well, waveform radiation would be able to pass right through, a thin foil shield because it's smaller than the atoms it's passing around. So it basically just passes right through when it's waving through. Whereas particles, if you have a foil made of something dense like gold, essentially there's no place for the particles to really get through. They're more likely to bounce off or essentially get hung up in the material. So foil works for particle radiation, would not work very well for waveform radiation. So other people claim that there's no way we could take video in the form of film, either video film or image film, because film would be destroyed in the radiation. Well, a camera or a film canister is sufficient to stop an energized particle from hitting the film just as much as foil is. Uh, an energetic particle would not expose the film. It would streak it if it grazed the surface, or it would create a dot if it passed through perpendicular. And just as a weird side note, when Van Allen belts were initially discovered, some believe they discovered the remains of a clandestine nuclear explosion had been set off in space, which is interesting, meaning that most people weren't predicting the existence of this. Uh, Another item I see popped up in some of the claims saying that the Apollo 16 crew should have died due to a solar flare. In fact, no such flare occurred during that mission. Another claim people make is that the astronauts went into orbit but didn't go to the moon. So the size of the Apollo suite, essentially the lunar module, the lander, uh, sorry, that's one and the same. The lunar module and the command vehicle were large enough that you would have been able to see it orbiting the Earth. If you've gone outside and watched the sky, you might be aware that you can actually see even the smaller satellites that are man-made satellites that are orbiting the Earth. Uh, the Apollo mission would have been fairly sizable and would have been very easily seen going around in orbit. The telescopes of amateur astronomers could have determined that the object was man-made pretty easily. National level telescopes and university telescopes of unfriendly countries could have easily resolved such a hoax. Uh, and then one of the things that's built into the communications is there's a radio delay drift that occurs between when they hear the ground talking to them and when they come back, and then the travel time in between. Faking the radio drift would have been an incredibly massive feat for that era, far beyond the computing technology that was available. The same people who complain that the computers were insufficient to get people to the moon would have been far more insufficient to come up with essentially faking the delay and drift patterns. Another claim people make is that a fake unmanned rocket went to the moon while the astronauts stayed in a small, hard to see capsule in orbit. Again, performing the relay between the surface to orbit to space and maintaining the radio drift would have been a fantastic feat for their computers, beyond what they were capable. And many people have torn apart the transmissions following it, and the drift patterns make sense compared to what was going on. Uh, Mathematically, it adds up. Some people would suggest that they could have pre recorded all the information that was coming from, the supposed moon landing and be put on this unmanned ship that goes there, and that would properly take care of all the drift issues, and that could potentially work. Uh, but obviously, if you have a recorded system playing back over a 3-day period, you have an immense danger of failure. And if they did this, they did this on several successful missions without there ever being an error. So let's say the people who believe that it's a hoax, if they're to be believed, wouldn't the radiation damage the recordings when it got bathed in the radiation? Wouldn't it pretty much destroy all the delicate equipment on board, unveiling the hoax before everyone's eyes? Another claim is that real men, but not the ones we know, went to the moon, received terminal amounts of radiation, and then were left to die there or came back to die on Earth. Well, so we can go to the moon after all. Why bother? The US could have still claimed victory by reaching the moon and then had some kind of massive hero's funeral for the brave astronauts. Uh, some people claim that there should have been more than a 2-second delay in the communications between Earth and the moon at a distance of 250,000 miles. The round trip light travel time of more than 2 seconds is apparent in all the real-time recordings of lunar audio, but this doesn't always appear as expected. Some of the documentary films have removed the delay in order to make it more coherent and easy to follow. Another claim that's made is that the Parkes Observatory in Australia was billed to the world for weeks as the site that would be relaying communications from the first moonwalk. And the claim says, however, 5 hours before transmission, they were told to stand down. Although it's true that the timing of the first moonwalk was changed after the landing, in fact, the delays getting the moonwalk started meant that the Parkes Observatory covered almost the entire Apollo 11 moonwalk. Parkes supposedly had the clearest video. This another claim. Parkes Observatory supposedly had the clearest video feed from the moon, but Australian media and all other known sources ran a live feed from the United States. That actually was the original plan. However, and was meant to be official policy. However, the Australian Broadcast Commission did take the transmission directly from the Parkes Observatory. This meant that Australian viewers saw the moonwalk several seconds before the rest of the world. Another claim is that better signal was supposedly received at Parkes Observatory when the moon was on the opposite side of the planet. This isn't supported by the detailed evidence, telemetry, and logs from the missions. Some people point out that the radio delays are not consistent. Well, yeah, that's true, and there's good reasons for it. You remember, one, the capsule's in constant motion, meaning it's either moving away from the Earth or coming towards the Earth. The Earth's rotation is also changing the distance constantly, because think about the Parkes Observatory as the Earth is rotating. It's either getting closer or further away from the ship as it's moving as well. So you have two different factors changing the distance constantly. So you're not going to have a consistent delay. Some people claim that rockets can't work in space because there's nothing to push against. Rocket exhaust doesn't actually push against anything. It's something we call action-reaction, or action pairs. Now, stand on a skateboard and pick up something like a garbage can lid or some kind of shield and just kind of push against the air. you won't move, or you maybe move just a little tiny bit. Now, if you stand on the skateboard with a bowling ball and you throw the bowling ball, you'll move back quite a distance. That's action reaction in practice. So it has nothing to do with pushing against. It's mass pushing against mass. Uh, Another claim is the second stage and lunar descent modules showed no rocket flame. Uh, that it was some kind of mess up on the part of NASA not to include that in their fake videos. Both engines, the lander and the second stage up high in orbit, are firing in low or almost no oxygen. So you're going to have a lot less flame because you don't have anything to combust. And you're also going to have rapid dispersal because you don't have any atmosphere resisting it. All right. That's where we're going to end this tonight. And we have some more claims coming up in the next video. So what do you think about the items we covered tonight? Feel free to mention in the comment section uh, if uh, you think that these claims aren't backed up properly. I can see if I can dig up some sources for you if you really need it. And if you haven't heard some of these claims before, tell me which ones are new to you and what you think of that. Please smash the like button. If the YouTube algorithm brought you here and you're not one of my regular subscribers, please take a look at my other video titles. I have a little bit of something for everyone. Please consider subscribing. I won't spam you. I do about several a week. I have a goal of daily, but I don't know if I'll get there yet. And if you know somebody who might find this interesting, please share it with them. I appreciate you spending time with me this evening, and I also appreciate you pointing out that we didn't have audio the last time I did this video. Uh, Hope to see you again in a future video.